So first, we are going to do oxidation reaction with another reagent. That is basically this is primary alcohol RCH2O, and if you are going to react this with copper at 573 Kelvin, it will be oxidized into aldehyde. It will be oxidized into aldehyde, and if it is secondary alcohol, and copper 5 at 573 Kelvin, then this secondary alcohol, 2 degree secondary alcohol, what do you think? What will be the product, aldehyde or ketone? Can you tell me?
Yes, suggestion. So will it be ketone?
Ketone, yes, it will be ketone. RC double bond O R dash. Again, the most important point is that if you have tertiary alcohol, CH3COH, and then CH3, and then CH3, when you are going to heat it in the presence of copper at 573 Kelvin, there will be the formation of alkene. There will be formation of alkene. It will be like CH3, C double bond CH2, and then CH3. So basically, you can see H2O will be eliminated, OH from here, and hydrogen from any carbon. That's a alkene form. So I can write a point about this. Yeah, first write it, then I will write the point.
Yes, sir.
Today we are going to finish this chapter almost, because after half an hour we are going to start ethers, preparation of ether, and then chemical reaction of ether, and its chemical reaction is not that much as compared to alcohol and phenol.
Yes, sir.
So let me know when you are done with this.
Done, sir.
So write a point about this reaction. When vapors of a primary or a secondary alcohol are passed over heated copper at 573 Kelvin, dehydrogenase takes place. You know what is dehydrogenase?
Yes, sir. Removal of hydrogen.
And aldehyde or ketone is formed while tertiary alcohols undergo dehydration. Do you know what is dehydration?
Yes, sir.
What is dehydration?
Dehydration. Removal of
Yes,
H2O.
H2, very good. Dehydrogenation, that means removal of hydrogen in primary and secondary alcohol, and dehydration will take place in tertiary alcohol, right?
Yes, sir.
So please write it. After this chapter, which chapter we are going to study?
Sir, electrochemistry.
Okay.
Done, sir.
Very good. So here are chemical reaction of alcohols completed. Now the next topic is basically the reaction of phenols. Reactions of phenols. To see what is basically reaction of phenols. So in this we are going to study electrophilic aromatic substitution. Electrophilic aromatic substitution. Benzene is an aromatic compound. So especially we are going to study phenols. That's why I wrote electrophilic aromatic substitution, in which the first part will be nitrogen. So can you tell me what does this nitrogen means? Nitrogen is addition of nitrogen, right?
Yeah. Yes, sir.
So basically when you are going to react this phenol with dilute HNO3, you will get two products, O-nitrophenol, that means orthonitrophenol and paranitrophenol. So we can write with dilute nitric acid, with dilute nitric acid at low temperature as low as 298 Kelvin. 298 Kelvin. Phenol is a mixture of, or phenol gives a mixture of ortho and para nitrophenols, ortho and para nitrophenols. So I'm going to write the reaction. You can see this is a phenol, and if you are going to treat this phenol with dilute HNO3, dilute HNO3, you will get two products. The first one is ortho, and the second one is para. So we can write the name O-nitrophenol, and this is P-nitrophenol. Are you getting my point? And this can be easily separated by steam distillation because their boiling point difference is more. That's why they can be easily separated by steam distillation. So please write it and write a point about this.
Done, sir.
Very good. And is we can and
So you're lagging, sir. I can't hear you.
am I audible? Am I audible now? Am I lagging?
No, sir. Now, sir.
Okay. So you can see this ortho and para isomers can be separated by a steam distillation. By a steam distillation. This O-nitrophenol, O-ortho-nitrophenol, is a steam volatile due to intramolecular hydrogen bond. Intramolecular hydrogen bond. Intramolecular hydrogen bond. While this p-nitrophenol is less volatile, that means basically more stable, is less volatile due to intermolecular hydrogen bond. Due to intermolecular hydrogen bond. So can you tell me what is intramolecular hydrogen bonding and what is intermolecular hydrogen bonding? Can you tell me?
The difference between intramolecular and intermolecular.
Yes, one is intramolecular and another is intermolecular. And due to this intermolecular hydrogen bonding in p-nitrophenol, there will
Yes,
be
sir.
association
Less
of.
accession of molecules. Yes, sir.
So can you tell me what is intramolecular hydrogen bonding and what is
I,
intermolecular hydrogen bonding?
sir, I don't know the definition correctly, sir, of
Okay,
both of
see,
them.
see what
It's yes, sir. You can continue.
intra is basically inside the molecules.
Yes, sir.
So
Okay.
see, this is O-nitrophenol. I'm going to draw. So we have a structure like this, and this is our O and H, and this is our N, and double bond O and O. So you can see the hydrogen bonding is within the molecule. That is called intramolecular hydrogen bond. Are you getting my point? Inside
Yes,
the
sir.
molecule, intramolecular H bonding. And this is basically O-nitrophenol. What it is?
Oh, nitrogen.
O-nitrophenol. But when we talk about p-nitrophenol, it will be intermolecular. That means between two molecules, two
Between two
different
molecules.
molecules,
Okay, yeah. Yeah.
between two molecules. So you can see N double bond O, and then O, and then OH. Wait a minute, please. And you can see this will be OH, and then again this is our benzene. This is N double bond O and O, and you can see this is OH. So between these two molecules, there will be hydrogen bonding. This is called intermolecular, between two molecules. So intermolecular H bond, and it is nitro. Are you getting my point?
Sir, lagging, sir.
Am I lagging right now? Oh, internet connection is low. Wait a minute. Am I lagging?
No, sir. Not now, sir.
No. See, I'm going to explain again. So you can see two molecules of this para-nitrophenol combined. Yes. Was saying anything?
No, sir.
Okay. So what I was saying is, you can see two molecules of para-nitrophenol form single molecules. That's why association takes place. Association, that means two or more
Addition.
molecules combine to form a single
Yes,
compound.
sir.
Yes, two or more compounds combine to form a single compound. That is association of molecules. Two or more. Are you there? Now it will be good.
Yes, sir. I'm there.
Can you see the screen? Let me know.
Yes, sir.
Okay. Please write it.
Yes.
Are you done with this?
Suggestions, sir. Done, sir.
Very good. Now see, if you are going to react this, we did this reaction of phenol with dilute sulfur HNO3. Now, if you are going to react this phenol with concentrated HNO3, what will happen? See, with concentrated nitric acid, with concentrated nitric acid, phenol is converted phenol is converted to 2,4,6 trinitrophenol, trinitrophenol, and also known as, it's the name of this compound is very famous. Picric acid, also known as
Picric acid.
not picric,
Picric acid. Sorry, sir.
Yes,
Picric
yes.
acid.
So you can see how the reaction will take place in the same way as the dilute HNO3 reacted with phenol. Only the difference is we use here concentrated HNO3. So when concentrated HNO3 react with this, you can see there will be OH, and with respect to this, there will be NO2 at position 2, and then at position 4, and then at position 6, and it is benzene. So this is our 2,4,6 trinitrophenol, trinitrophenol, and also known as picric acid. Please write it. Then we are going to do halogenation, and after that there will be some name reaction which is very important. Then we will start ethers. Are you done with this?
Yes, sir.
Very good. So after nitration, we have electrophilic aromatic substitution reaction. The second part is halogenation. That means addition of halogen. So how addition of halogen will take place in phenol? So basically, first of all, we are going to treat this phenol with bromine. So I'm going to write a point on treating phenol with bromine. On treating phenol with bromine. A part. When reaction, different types of compounds will be formed depending upon the situation. The first condition is depending upon the condition. The first condition is when reaction is carried out, in solvents of low polarity. Polarity is low, such as CHCl3 or CH2, and at low temperature. Then monobromophenol form. Monobromophenol form. As you can see the reaction, if you are going to react this phenol, this is our phenol, Br2 in the presence of carbon disulfide, Br2 and CH2 carbon disulfide at 273 Kelvin. Then Br will be added at ortho and para. So can you tell me which one will be more stable? The ortho one and the para one. And can you tell me the IUPAC name of the products?
Sir, the para will be more stable, right?
Yes, what will be its name?
Its name, just 4.
For what?
For so will it be 4 bromo?
Phenol. Is it?
Yeah, 4 bromo
It's
phenol. Sorry, 4 bromo phenol. Yes.
So it will be.
Yeah.
This will be major, and its name will be 4-bromo
Phenol.
phenol. And you can see its name will be
2-bromo phenol.
Phenol, and it
Yes,
will be
sir.
minor, right?
Yes, sir.
Please write it. Let me know when you are done with this. Are you done with this?
Yes, sir. Yes, sir.
Now see, this was the first condition of the reaction. The second condition, you will see, when phenol is treated with bromine water, when phenol is treated with bromine water, 2,4,6, try
Try.
bromophenol, tribromophenol is formed
Yes, sir.
as white precipitate. White precipitate. So if you are going to see the reaction, you will easily understand there is phenol, and you are going to react this phenol with 3Br2. Then you will get a product like this. OH, with respect to this is at second position. This
Yes,
Br is
sir.
at fourth position,
Try
and this Br will
bromophenol.
be at sixth
Yes, sir.
position, along with a byproduct of 3HBr.
3 HPR. Yes, sir.
Please write it. Harsh, can you hold a minute? I will be back from taking water.
Yes, sir. Yes, sir.
Are you there first?
Yes, sir.
So are you done with this?
Yes, sir. Yes, done.
Now there are some name reaction that is very important from this chapter. And the first is basically coal-based reaction. Coal-based reaction. Coal-based reaction. So what does this coal-based reaction means? So basically, phenol is treated with sodium hydroxide, sodium hydroxide, and phenoxide ion will form. Phenoxide ion will form, which is more reactive which is more reactive than phenol towards electrophilic aromatic substitution. Towards electrophilic aromatic substitution. Now you can see, and it reacts with carbon dioxide, carbon dioxide, which is a weak electrophile, which is a weak electrophile. But still it reacts because it is very reactive, unstable. Then ortho hydroxy benzoic acid, benzoic acid is formed as main product. So you can see, if you are going to treat this phenol, if you are going to treat this phenol with the sodium hydroxide, so it will give you phenoxide ONA, and this is very reactive than phenol. So when CO2 will come near this in the presence of acid, what will happen? First, Na will be replaced by this H, so it will be OH, and there will be C double OH. And this compound is basically called 2-hydroxy
Hydroxy
benzoic acid,
benzene.
benzoic acid, or its common name is very important to remember and keep it in mind. Salicylic acid. What it is?
Yeah, salicylic acid.
Salicylic acid. It is salicylic acid. Please do.
Yes, sir.
We had already done the nomenclature of ethers, right?
Yes, the first. Yeah, we have done, sir. Wait, sir, let me just check. Done, sir.
Very good. Now the next reaction you can see is a Rimmer-Tiemann reaction, which is very important. When I had given 12th board, then this question was asked. Rimmer-Tiemann reaction. So what is this Rimmer-Tiemann reaction? See, basically on treating phenol with with chloroform in presence of sodium hydroxide, a CHO, that means aldehyde group, is introduced at ortho position of benzene. At ortho position of benzene. This reaction is known as Rimmer-Tiemann reaction. This reaction is known as reaction. Now see, the important question is that there will be formation of intermediate. That intermediate is very important. The intermediate substituted benzyl chloride is hydrolyzed in the presence of alkali to produce salicyl aldehyde. You can see the reaction. First, there is phenol, and this phenol is treating with chloroform, that means CH3 in the presence of aqueous NaOH. In the presence of aqueous NaOH, and then an intermediate is formed. This is the intermediate, you can see. CHCl2, O minus Na plus. This is our intermediate. And this intermediate treated with alkali NaOH, then a phenoxide ion will be formed introducing CHO at ortho position. And when this will be treated with H plus in presence of acid, you will get OH here and CHO here. 2-hydroxybenzaldehyde, or its common name is salicyl aldehyde. Please write. Hers, are you there?
Yes, sir.
Please write it and let me know.
Yes, sir. Yes, sir. Just got disconnected. Sorry.
Yeah, I just noticed it.
Done, sir.
Very good. So, do you have any doubt in this reaction? Now see first.
So
The
just one,
next
sir.
reaction, the next reaction is reaction of phenol with zinc dust. So basically, this reaction is very easy. Phenol is
Yes, sir.
converted, and this reaction is very important, converted to benzene on heating with zinc dust. On heating with zinc dust. So you can see if you have phenol and you are going to react this phenol with zinc and heat it, then you will get a benzene plus Z.
Done, sir.
Very good. Then the last chemical reaction of phenol is basically oxidation. So we are going to oxidize this phenol and see what will form and how it is going to be oxidized. So basically, oxidation of phenol with chromic acid with chromic acid produces conjugated diketone. There will be diketone, two ketone group, known as its common name is benzoquinone. Benzoquinone. It can be asked like write the structure of benzoquinone in 1 marks. Okay.
Yes, sir.
In the presence of air, phenols are
So can you draw the structure of benzoquinone?
I will. Phenols are slowly oxidized to dark colored mixtures. To dark colored mixtures containing quinones. To see what is the structure, so I'm going to write the reaction and you will know. This is a phenol. If you are going to react this with Na2Cr2O7 in the presence of H2SO4, this will be oxidized into diketone, which is known as benzoquine. This is benzoquine. Are you getting my point?
Yes, sir. Done, sir.
Very good. Here our chemical reaction of phenols are completed. Now we are going to talk about ethers. So we already talked about the, I already taught you, how to do nomenclature. So we are going to start. Do you have any doubt in nomenclature?
Nomenclature, just start, sir. Just start. Revise, sir. No, sir, I don't think so.
So what do you think that what does this means? Do you
No, sir,
have
no
any
doubt.
doubt? No doubt.
No, sir.
Ethers. So we are going to start basically preparation of ethers. And the first from where?
By dehydration of alcohol.
Yeah, by dehydration of alcohol. See, by dehydration of alcohols, we already saw that there was formation of alkene in dehydration of alcohols. So I'm going to write a point. You have to be clear about this. Alcohols undergo dehydration in presence of protic acid, in presence of protic acids like H2SO4, H3PO4, H2SO4 and H3PO4. The formation of the reaction product, the formation of the reaction product either it will be alkene or ethers, depends on the condition, depends on the condition. Like I'm going to show you the dehydration. First write it and let me.
Yes, sir. Done, sir.
So you are going to see the condition and you will see there is a phenol CH3 CH2OH, and if you are going to dip this in H2SO4 at 443 Kelvin, then there will be the formation of alkene CH2 double bond CH2. And if you are going to dip this in H2SO4 at 413 Kelvin, that means lesser than 30, basically 30 degree lesser than this, then there will be the formation of CH3, CH2O, CH2, CH2. Now tell me the name of this, IUPAC name of this and this.
So
Yes.
won't the second one from C2H5O, C2H5O?
Yeah, that is same now. C and C, C2,
Oh, yes,
3H, 2H,
sorry.
H5. It is the same.
Yes, sir, yes, sorry.
No problem. Tell me the name of Ayurvedic name of the products, both products. First,
So can you hear me?
yes, I can.
Yes, sir, I understand. So first one is ethene, sir, right?
What about the second one?
Second one. It should be, so what is the second one, sir? Can you please?
What you just said?
Can you just tell the second one, sir?
So see, both sides,
The
same
second
number
one.
of carbon.
Yeah, same
So we
number
can
of
choose
carbon
any
atoms.
as branch and substituent and parent name. So its name will be
Yeah.
ethoxy.
Ethane, ethoxy,
Yes.
ethane, yeah.
Now I'm going to
So,
write the mechanism.
okay.
Are you done with this?
Okay. Sir, I have to
Are you
write
done?
this, sir.
Okay, please
I have to
write it.
write this. Just transfer, yes. Done, sir.
Very good. Now going to show you the explain the mechanism behind this. First of all, this reaction, or we can write the formation of ether is a nucleophilic bimolecular reaction. Bimolecular reaction, that means SN2 reaction, involving the attack of alcohol molecule on protonated alcohol as follows. You can see, I'm going to write the mechanism. The first state. This is an alcohol, that is ethanol, CH3, CH2, and OH. And you know that oxygen has two lone pair, yes or no? So this lone pair, and it will be attacked with H plus. That means we are going to make this alcohol protonated alcohol. Am I audible? Are you there, Harsh?
Yes, sir. Yes, sir. Yes, sir.
So this will be protonated alcohol now. OH, there will be positive charge and the hydrogen will come here. There will be bond between oxygen and hydrogen. Now, the second state is going to take this as reactant. So what happens here? This is protonated alcohol, CH3, CH2, OH, and this is basically alcohol, ethanol, and going to react this with CH3, CH2, this alcohol, this protonated alcohol, and it will be like this, OH, H, and O. There will be positive charge on O. Can you tell me, positive charge on oxygen is less stable or more stable? Positive charge on oxygen is less stable or more stable?
Positive charge on oxygen is more stable.
No, you also said the same
No,
answer
no,
in
it's
the
negative charge. Yeah, it's less stable.
electronegative.
Less
That's
stable.
why it is less
Yeah,
stable.
electronegative less stable.
So
Yes, sorry.
what happens here? This oxygen will basically oxygen wants to get stable, so it will take electron from carbon. Now this carbon will be electron deficient compound, so this oxygen will attack this carbon. So you can see what happens. So if this oxygen will take electron from this carbon, H2O will be eliminated, and you can see this CH3 I'm going to write, then CH2. Now this CH2 will have a positive charge, at the same time gained electron by this oxygen, from this oxygen, so there will be negative charge also, and this is CH2 and CH3, and this is like this positive. Are you getting my point? This oxygen gives one electron to this carbon, so this oxygen will have positive charge, and this carbon will have negative charge. But at the same time, this oxygen withdraw electron from this carbon, so there will be positive charge also. So positive negative will be cancelled. Are you getting my point?
So can you explain because I got disconnected. Sorry.
So see what happens here. What happened here? Are you able to understand the first step, or I should explain from the first?
So the second one, sir.
Second one. So you can see this is alcohol, ethanol, and this is protonated ethanol, protonated alcohol. As I asked you that, is positive charge on oxygen is less stable or more stable?
Less stable.
So in order to get a stability, this oxygen will withdraw electron from this carbon.
Yes.
So if oxygen will withdraw electron from this carbon, this will have positive charge, yes or no?
Yes, yes, sir.
And this, if there is positive charge, that means this is electron deficient compound, yes or no?
Yes, yes.
Now you can see the another alcohol, ethanol, is here, which is electron rich species. So this oxygen will attack this carbon. So it will donate one of electron. So there will be positive charge on this oxygen because it is donating electron. And this carbon will have negative charge, and already there is positive charge. So negative positive will be cancelled, yes or no?
Yes, sir. Yes.
So you can see I'm going to write this CH3 CH2 first. So this CH3 CH2. Now this oxygen donated electron to this. So now oxygen will have positive charge and this like this. Okay.
Yes, sir.
Now the third step is like this: CH3, CH2, O positive, H, and then CH2, and then CH2. Can you tell me positive charge on oxygen is less stable? That's why this
Less stable,
oxygen
sir.
will take electron from oxygen, from hydrogen,
Oxygen.
and now it will form ether. And this H
Ether.
plus proton will be eliminated. So we can write C2H5O and C2H5. I'm going to slide it up. Please write it.
Yes, sir.
Are you done with this one? This line?
Sir, I'm on the third one, sir. Can you just scroll, just keep it down, sir. Just write the third one.
Okay, good. Should I slide it up like this or downward?
No, so downwards. I'm on the third one. I'm writing the third. CH.
Oh,
Sir, I think you slide it. Okay, now it's fine, sir. Thank you. Done, so. Sir, done.
are you done with this? Very good.
Yes, sir.
So you can see the proton that we used in the first step is eliminated in the last
Yes.
step. Yes or
Yes,
no?
sir. Yes, sir.
Very good. So wait a minute. And text question. I need to give you some question now. How's your preparation going?
Sir, it's good, sir, but I guess we have
So,
exams in October, unit test. So like it's 2 chapters.
2 chapters only.
Yeah, it's unit test, sir.
Okay.
And then midterm is maybe in November.
So if you are going to treat butanol with HCl in the presence of ZnCl2, oh, wait a minute. Wait a minute. Yes, no. Can you write the name of the product? Can you do this? Harsh, Harsh, are you there? Yes, yes.